All right, it's recording. Here we go. 5H, factorizing expressions. This is what I want you to copy down. Factorizing is the opposite of expanding. It's by putting terms into groups. So expanding, okay, means that you're going to get many terms. Whereas factorizing, you're going to simplify the number of terms. I want to give you an example afterwards, but we're going to practice doing this one first, okay? Let's take this example. Yesterday, I taught you how to expand that term there. All right, I taught you how to expand those brackets. So let's recap on what we need to do. The number on the outside is a 3. How do I expand the brackets here? Let's go with, who was here yesterday? I'm trying to remember. Oliver. What's the first step? What do I do to expand the brackets? Mateo, I said no laptop. Right now you're writing. You do it afterwards. You do it afterwards. Yeah, 4 assignments. You're going to take the notes afterwards then?
Still mine.
All right. Sorry, Oliver. 3 times A. So we're going to go 3 times A, and I want you to write the steps out. 3 times A. And the reason why I want you to write steps out is because when you start working with negatives, those students who skip the steps are also the students who often make mistakes. So I want you to make sure you're writing those steps out so it's clear where the double negatives will end up coming. Okay, so here, first one is 3 times A. Very good. And then the second step, what is the second step? Can I please have Liam? What do you do next? Very good. It's 3 times the 1. So we write it out. It's 3 times 1. What's separating the two terms? Plus. Very good. Then we simplify it. So the next line, you can now simplify it. And you can then say 3 times A, which is equal to what, Sully? 3A. Next one, Kyle. Beautiful. Okay, so this now gives you, notice how many terms there are. There are 1 term separated plus sign. Now you've got 2 terms. This is 1, 2. So you got 2 terms there. From this step to this step, that's called expanding. From this step, which is what we're doing today, to go backwards, it's called factorizing. Factorizing is meant to put it into groups because you then simplify the number of terms. Right now, this might be a trick question. Let's see how many people can answer that question. This expression, 3 bracket A plus 1, how many terms is that? Hands up if you think you know. Kyle. It's 1. Now, if any of you thought 3, wrong. If you thought 2, also wrong. It is 1. Okay, because we say 3 bracket. Now think about it. 3 bracket A plus 1. This actually means 3 times A plus 1. So what's in between this is not a plus or minus. Doesn't separate it. This is technically 1 term. Just like the same way if I wrote 3A, you told me that's 1 term. What's separating these two is 3 times A. So you don't say that's 2 terms. That's 3 times A. So the same thing for this one. This is 3 times A plus 1. Together, that's 1 term. So when you factorize, it actually simplifies the problem. This is only 1 term. This is actually 2 terms. Okay? And that's the idea of factorizing. Now, just to give you a logical explanation, remember yesterday I talked about classes? I said that you can have 8A class, 8B class, 8C class, 8D class, 8E class. I actually don't know if there's an 8C, but let's just go with that, okay? How many classes are there? Can I please have Leon? How many classes do you see there? There are 5. There's class 8A, class 8B, class 8C, class 8D, class 8E. So these are like your terms. That's 1, 2, 3, 4, 5. 5 different classes. They're not the same. Yeah? So 5 different terms. You can't add them together because they're all different. But the nice thing about all 5 classes is what? What do they all have in common? 8, right? They're all common that they're all year 8s. Now, why did I spend so long writing 8A, 8B, 8C? I'm repeating the 8. I'm writing the 8 so many times, right? Wouldn't it be better, since I already know they all are year 8s, isn't it just easier and quicker if I just said 8 is my year 8s? So if I put an 8 at the front, it just means these are my year 8s. And now how many year 8 classes do I have? Well, I've got A. That's one class, 8A. That's my second class, 8B. They're different. See how they're different? They're not the same. Well, what did they have in common? They were all year 8s. But together, it's 8A, 8B, 8C, 8D. Wasn't it just easier to write A plus B plus C plus D plus E? I only write 8 once. I don't have to write it 1, 2, 3, 4, 5 times because we already know it's year 8. But can you see what I've just done there? This is factorizing. I made it one group. So if I had it in an Excel spreadsheet, can you imagine I would have year 8, year 9, year 10, year 11 is just grouped. That's what factorizing is. We're grouping. We're saying these are the year 8s group. And then you just count them. And you say, well, in the year 8s, how many different classes do you have? You've got 1, 2, 3, 4, 5 different classes. I didn't have to write 8 each time. But if you expand the brackets, then you can say, well, it's 8A, 8B, 8C, 8D, 8E. And isn't that just what we're doing? Mathematically, that's what we're doing. When we expand it, you're doing 3 times A, 3 times 1. That's what this is. It's just a way of organizing data that it's just quicker or easier to see. But what I want you to see in this idea is what's outside on the bracket. I want you to write this in so that you remember, because that's what the whole exercise is about. This is common. Outside is what's common about each group or each person or each team. Inside the brackets, which I'm going to highlight now. Actually, maybe I should do it in green. A, B, C, D, E is everything that's different about each person. That's what's different. So what's common? What's inside the brackets is uncommon. They shouldn't have anything that's the same. Everyone's different there. And it doesn't have to be year 8 class. It could have been boys and girls in this classroom. I could have done the same thing. I could have said, we can put B for boy, and I could say Hauschwan. So BH is Hauschwan. And then I could say B for Tom, I could do BT. I could go over here and say BS for Sully, and he's a boy. But I don't have to write BH, BT, BS, and then G, Wendy. I don't have to do that. See, they're different groups. But what's nice is G, Wendy to, let's say, G, Kim. And then we go, all right, well, let's put all, sorry, just put your surname there. But let's put it all together here. We've got G, I'll just put E again, Elizabeth. So we can see now, if we took the groups, they're all different groups. They're different people. Every one of these people are different. They're not the same. So there are 1, 2, 3, 4, 5 different students. But what do the students have in common? The boys have the B's in common. So if I just said, who's in my boys group? I can do B. That's what's in common. What's uncommon? Hauschwan is different to Tom. Tom is different to Sully. That's why we put a plus between them. So Hauschwan is different to Tom. Tom is different to Sully. But what they all have in common is they're boys, right? Or at least that's what we're identifying as. And then G, I can then say, well, in the G group, I've got G, W plus E for Wendy and Elizabeth. They're different. So what are we saying here? We're looking at when we're factorizing, we're looking what's common goes on the outside, what's uncommon goes in the inside. And so you might think, well, what other benefits of knowing these things? Well, when you're doing like biology, you're doing animals. There are like mammals versus reptiles, and you write mammals on the outside, what's common, and then what's different about them. Some mammals have 4 legs. Some mammals have 2 legs. Some mammals have wings, right? And so each one is different. And so being able to group and not group, that's the idea. So what goes inside the brackets is uncommon, and what goes outside the brackets is common. Yeah, that's it. Okay, so that's what we're doing today. Today in the exercise, as you're doing the mathematics, you got to think, well, how does this apply to what we do? So we're going to do some examples. We're always going to find what's common first and then figure out what's uncommon about each one. Yeah, so let's go. Let's go down here. So in the space here, we need to first find, and I want you to write in here, highest common factor, or HCF, between the terms, because that's what our goal is. Our goal is to find what's common about each different term. So fill that in. So how to factorize expressions? How do we group things? We group it by first finding what's common. Okay, just like how I just did it just now. I just did the boys versus the girls, or I did the year 8 for class A, class B, class C. See the difference? Let's do some simple example here. So this is a bit different. This is just now numbers and terms. But this expression here, how many terms do I have here, Colleen? How many terms do you see? 2. So at the moment, I've got 2 different people. Yeah, 2 different groups. Just like Halshwan, Tom, Sully, they're different. But I'm going to look for something that's common about them. So let's break it apart. 5x and 15. Now let's break out 5x because we're talking about factors, right? Factors, let's deviate for a bit over here. 12. What are the factors of 12? Give me 2 numbers that multiply to give you 12. Yes, Kyle. 1 and 12. Okay, so notice it's 1 times 12. If you times them together, you get 12, then they become factors. So 1 is a factor, 12 is a factor. Give me the 2 numbers. 6 and 2. So 6 times 2 gives me 12. So every time you multiply and it gives that final result, it is a factor. So 6 is a factor, 2 is a factor. Give me another one, Ava. 4 times 3. So what's pattern here? How do you know which ones are factors? That's a factor, 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 that's a factor. But how do you know it's a factor? It's when the timesing. So when you read this, what does 5x actually mean again? What's between the 5 and the x? What's actually happening, Sully? 5 times x. But if you're timesing them, can you see how it's the same? I'm color coding it now. 5 must be a factor, and x is a factor of this term, right? But the nice thing is with numbers, we know a bit more about numbers. What are the factors of 5? Can you break 5 down even further? What 2 numbers that multiply to give you 5? Let's go, Elliot.
2.5.
No, whole numbers. 2 numbers, 1 and 5. So 1 times 5, can you see what are my factors of 5x? It was just 1. 1 times 5, that makes 5. So 5 is a factor of 5x, but then x is also a factor of 5x. So how many factors do I have so far? It's 1, 5, x. 3 factors. Then you do the same for 15. Nice thing about 15 is you just think about the numbers that multiply to give you 15. So let's break it apart. Give me 2 numbers that multiply to give you 15. Ashwin? 5 and 3. Good. So 5 times 3. These 2 are factors because you're timesing. Yeah, so again, I'm going to color code them again. Every time you times, you get a factor. So 5 and 3. What else? Give me another 2 numbers. Yes, man. 1 and 15. 1 times 15. Again, you're timesing. Every time you multiply and they get the result, it is a factor. So if you have a look at the 2 lists, let's write out the list so far. So list for number 1, list for the first group, for the 5x group. For 5x, the factors were 1, 5, and x. That's what you figured out. So 1 times 5 is a factor of 5, and x is times 5, so x is a factor as well. So this is my 3. Let's look at the factors for 15. 15, when you list them out, you've got 1, 3, 5, and 15. So we write down 1, 3, 5, 15. So now we can look at these 2 people, 5x and 15. What do they have in common? We've got a 5. Just like when I break down Halshwan, Tom, and Sully, there must be something that's going to be in common. They're not always something in common. They might be wearing the same jacket. They might have different hair colors. There might be different heights, right? But there's something in common about them. So they could be boys, could be the jackets, could be the uniform, could be the pants. So I'm doing the same thing here. I'm just listing out all the things about one student. I'm listing all the things about another student. And then I find what's common. There's got to be more things in common. So this could be, they're both wearing the same pants. And this one, they might be both wearing the same jacket. Who knows, right? But when we say highest common factor, we're looking for the largest number that is in common. So in this case, what is my highest common factor? Can I please have, let's go with Josh. What's the highest common factor? 5. 5 is the largest number that they both have in common. So that means, here we go. So I know I'm showing a lot of steps here, but it's for those who haven't ever done factorizing before. You can do it much faster than what I'm showing you right now. But I'm showing you a theoretical understanding as well. Thanks, Elliot. All right. Why do we need to first find highest common factor? Once you know what's in common, remember, how do we factorize again? We had 5x plus 15. 5x plus 15. You told me what's in common. The highest common factor was 5. So we take out the 5. Remember, what's outside the brackets is what's common, because I'm trying to group them. I'm trying to find what's in common, yeah? So they both have a common factor of 5. So what's uncommon? Yeah. This one has an x, because 5 times x, if you think about it, 5, what are you multiplying to? You're multiplying to x. This one, they also have a 5, but what are you multiplying to? You're doing 5 times 3. So they're different. This is 5 times x. This is 5 times 3. That's why one group has an x and the other one is a 3. Because here you said, how did you get 15? It was 5 times the 3. Here, how did you get 5x? You did 5 times the x. They both have a 5, so what don't they both have? They both don't have an x or a 3. That's what's different. That's why we say this bracket here, or outside the bracket, is what's common, and this one is uncommon. That's what we're doing. Because the 5x was made up of 5 times x, whereas 15 was made up of 5 times 3. So you can see there that clearly they both have a common factor of 5, and what they don't have in common is the x and 3. That's why the x and 3 goes inside the brackets. That's what's uncommon. Okay, so you can kind of think of it in a theoretical sense and then think about the application to it. How does it apply in real life rather than just doing the maths to it, expand, factorize. Yeah, so just understanding the logic to what we're doing.
Wait, so can the highest common factor also be like a letter?
Yeah, it can be too. It can be a letter as well. That's right. Very good. So it doesn't have to just be a number. It can be a letter as well.
And they can also be like, for example, A, B.
Yeah, it can be. Yeah, very good. All right, let's do more examples. So I'm going to speed it up now. I'm going to speed it up so you get used to it. So let's break it apart. Let's do the next one. How many terms do I have in my second example? Can I please have Lucas? How many terms do you see? You see 3. Very good. There's 1, 2, 3. So there are 3 terms. There are 3 different people. But then each person must have something that's in common. So let's find it. Let's see what each one means. This one means when you write a 2 next to an A next to a B, what does that actually mean? Good. 2 times A times B. So these are all factors because you're timesing them together, so they must be factors. So 2A times B will give you 2AB. Then you break out the same thing for 4 and A. Let's break out 4 and A. What does 4 next to an A actually mean? Let's go with Elliot. When you write 4 next to an A, it means 4 times. Yeah, that's it. That's all it means. We're just too lazy to put the times. Yeah, so 4 next to an A means 4 times A. So that means 4 is a factor with A. But here's a problem. Can you see the list? 2A and B. Now, they both have an A, but just the number itself, that's a 4, that's a 2. That doesn't look like it's in common. Can we find one that might be in common? So we break the 4 a bit further. Give me 2 numbers that multiply to give you 4. How, Sean? 2 times 2. So we do have a 2. A 2 is a factor, but then you could also have, what's another 2 numbers that multiply to give you 4? 1 and 4. So you got 1 times 4. So at the moment, even though I know 4 is a common factor, I can see there's a 2 and a 4. So 2 at least is in common with this list, and A is in common with that list as well. But you have to check all 3. So you break out the last one as well. Let's break it up. 8A, 8AY means 8 next to an A next to a Y. So what does it mean? It can break up into?
8 times Y times A.
Beautiful. A times A times Y. So that means A is a factor, Y is a factor for this list, and 8 is also a factor, but the problem is 8 does not look like anything in common with these ones. So we break the 8 even further. We look for factors that are in common in all three. So here we go, we break it apart. Give me two numbers. Two numbers that multiply to give you 8. Yes, Liam? 2 and 4. 2 times 4. So 2 and 4 is a factor, but I can break the 4 further into 1 and 4. So you can see here the factors were 2, 4, and 1. But what's in common in all three of them? Now, all three of them, they have a 2. Very good. They all have a 2. So 2, 2. And they all have an A and an A. Can you see that? So what's different? What's different? So if we were to write the highest common factor, if we were to factorize it, highest common factor, you already said it was 2A. Great. So if we were to factorize it now, 2AB plus 4A minus 8AY. Here we go. You told me 2A goes on the outside. That's what's in common. So now you have to figure out what's uncommon. So what's uncommon? Let's think about it. 2A, you need to multiply 2B. See that missing one? This color here? That B, that's what's missing. 2A times B, that's how I get 2AB. What about this one? I chose 2 times A. What am I missing to get a 4? 2. So that's why this 2 is key, not the 4. So the 2 goes here now. This is where my plus 2. That's why 2A times 2 will give me that 4A that I wanted. Then you look at the same thing for this one. You said you've got 2A, so you've got a 2 and an A. But what am I missing? Yeah, I'm missing that minus 4, and I'm also missing a Y. See the ones I've colored? I'm missing the 4, I'm missing the Y, I'm missing the 1. But if you times them all together, 1 times 4 times Y gives me minus 4Y. This is what's uncommon. Uncommon. This is what's common. See, when I write the list, it becomes very clear. I've just highlighted what's the same, and then I wrote down what goes inside the brackets is literally what's left over. It's the multiplication of what's left over. What isn't the same in each group or in each term. I know a lot of students may actually not do it this way. A lot of students do it intuitively, and it's probably faster to do it the intuitive way, is that you ask yourself, 2A times what will give you 2AB? And you're like, well, missing B. And then you say, 2A times what to give you 4A? And you're like, well, 2A times 2. And then you say, 2A times what to give you negative 8AY? And then you'll know, well, 2 times negative 4, and then you're missing a Y. That's how you would do it, and that's fine. But I found that when I teach students who struggle with the timesing bit because they haven't practiced 5C, 5D, then me asking that question actually challenges the students. But if you list it out and you look at the letters, which one's in common, and then what's left over, that could also help you. If you haven't done 5C, 5D, that's another technique. So it's longer, but it builds your understanding of what a factor is. So I'm giving you 2 techniques there. Okay? All right, team, that's it for today. On the back of the sheet, it is your shot to try. The solutions are ready on OneNote. I already made the solutions for them. Check if you're getting them right before you try the exercise. I just want to make sure that you know how to do them. All right, team, this is your time. That was 23 minutes of my explanation. I'm going to stop.